In this video, I'll explain how to solve some questions from grade 10, 11 and 12. Question 1. The diagram shows a triangle ABC. It is given that AD equals to 7 minus square root of 5 cm and the area of triangle ABC is 16 plus 4 square root of 5 cm square. Find the exact length of BC. So this is the solution. Firstly, you have to see the triangle ABC and there is a point D between B and C such that AD is perpendicular to BC. So as we can see from the diagram, we will know that the area of triangle ABC equals to half of BC times AD. BC, as we have known, is the base of the triangle ABC and AD is the height of the triangle ABC. So BC equals to 2 times the area of the triangle ABC all over AD. By substituting the value of the area of triangle ABC, we know that BC equals to 2 times in bracket 16 plus 4 square root of 5 all over 7 minus square root of 5. And by multiplying by the conjugations, by means the rationalizing the denominator of this fraction, we will have this, and by multiplying all the brackets, all the inside the brackets, we will have the fraction like this, and simplifying will give the result 6 plus 2 square root of 5 centimeter. That is the final result and the exact length of BC. Question 2. Find the value of 1 all over square root of 4 plus square root of 5 plus 1 all over square root of 5 plus square root of 6 plus 1 all over square root of 6 plus square root of 7 until the addition up to 1 all over square root of 19 plus square root of 100. Solution. We may see from the series that each term of the series has a pattern like this: 1 all over square root of n plus square root of n plus 1, which is the same form to the square root of n plus 1 minus square root of n by rationalizing the denominator in this fraction. So, like 1 all over square root of 4 plus square root of 5, it could be reduced into the form of square root of n plus 1 minus square root of n. So as we may see from the question, it will be, and by applying the formula that we have this result: 1 all over square root of 4 plus square root of 5 could be square root of 5 minus square root of 4 using this formula. So each term will be in this formula, square root of n plus 1 minus square root of n. So after we reduce it into this formula, so we can have a telescope value like square root of 5 and minus square root of 5. Then we can cancel them all together. So it will be left to be square root of 100 minus square root of 4. Square root of 100 is 10 and square root of 4 is 2. 10 minus 2 equals to 8. Question 3. A man is 13 times as old as his son. In 10 years, he will be 3 times as old as his son. Find their ages today. And this is the solution. Firstly, you have to model these questions, or to understand these questions first before we are solving it. The first one is the age of the man today, let's say M, and the age of the son today is S. And after 10 years, of course, the age of the man will be increasing by 10. So we'll write M plus 10. And the age of the son in 10 years will be increased by 10. So we will write S plus 10. In the question, a man is 13 times as old as his son. It means that today M equals to 13s. In 10 years, he will be 3 times as old as his son. So we can write like this. M plus 10 is the age of the man in 10 years, and S plus 10 is the age of the son in 10 years. So this equation is valid. And of course, because we have M equals to 13s, we can substitute it directly like this. 13s plus 10 equals to 3s plus 30 by multiplying 3 inside to the bracket. So by having the similar terms or the like terms, we will obtain 13s minus 3s equals to 30 minus 10. 10s equals to 20, s equals to 2. So the age of the son today is 2, and the age of man today is 26. Question 4. A piece of wire of length 24 cm is bent into a rectangle. Let x cm be the length of one side of the rectangle and a cm square be the area of the rectangle. Find the range of values of x such that the area of the rectangle is greater than 27 cm square. So this is the solution. Firstly, let's try to figure out what happens to the rectangle. The first one, the piece of the wire will be bent into a rectangle like this, and of course, according to the question, x will be the length of one side of rectangle. So let's say this one is x, so the parallel side of the rectangle will be x2, so we have 2x here. By assumption that all wire will be used to create this rectangle, of course the length of one side of this side will be 24 minus 2x divided by 2 because we have two sides. Okay, and after that we simplify. The length of the other side will be 12 minus x. So this one will be 12 minus x, and this side is also 12 minus x. So let's call the area. The area is the length times width, which is equals to 12 minus x times x in bracket 12 minus x. So multiplying this will give the result 12x minus x squared. This is the area in terms of x. According to the question, we want to find the range of the values of x such that the area is greater than 27 cm square. It means that the area should be larger than 27, or 12x minus x squared larger than 27. Because we see that this term x squared, it means that we want to find out something in the quadratic inequality. So by rearranging this inequality, we'll obtain this 0 larger than x squared minus 12x plus 27, or in the other words, x squared minus 12x plus 27 is less than 0. Luckily, x squared minus 12x plus 27 can be factorized to be x minus 3 times x minus 9, and which is less than 0. So from here we will obtain that x is between 3 and 9. So the range of values of x such that the area of the rectangle is greater than 20 centimeters square will be between 3 and 9 centimeters. Question 5. A travel agent surveyed 100 people to find out how many of them had visited the cities of Pekanbaru and Padang. 31 people had visited Pekanbaru, 26 people had been to Padang, and 12 people had visited both cities. Find the number of people who had visited neither city. The solution is let the universal set equals to u, and this is the rectangle showing the Venn diagram for the universal set. And let's say that A equals to the set of people who had visited Pekanbaru by this circle, and B the set of people who had visited Padang by this circle 2. 31 people had visited Pekanbaru. It means that A equals to 31, and 26 people had been to Padang. B equals to 26, and A intersection B equals to 12 because 12 people had visited both cities. And of course, the total or the universal set will be equals to 100 people. So we talk about 100 people in the survey. Since the intersection A and B equals to 12, so we can put the number 12 inside the intersection of the circle A and circle B. Hence, the number in A only, without the intersection, equals to 31 minus 12. 31 minus 12 equals to 19. So we put the number 19 here. Number in B, of course, because total of B is 26. So number in B only equals to 26 minus 12, which is 14. So we put number 14 here. If we sum all the numbers here, 19 plus 12 plus 14 will be 45. Since the total of the people in the survey is 100, or EU equals to 100, so the other people who had visited neither city or who had not visited yet equals to 100 minus 45, which is 55. So 55 is the number that we put outside the circle A and circle B. Question number 6. Given that sine A equals to 3 over 4, A in the second quadrant, find the value of cosine A. This is the solution. Since sine A equals to 3 over 4, let's try to construct a right angle triangle based on the definition. And let's say this is the angle A inside the right angle triangle. It means based on the definition, sine A equals to 3 over 4, which means the opposite side equals to 3 and the hypotenuse of the triangle will be 4. And that also means the other side, using the Pythagorean theorem, will be square root of 4 square minus 3 square equals to square root of 7. Based on the definition of the cosine, cosine is the adjacent square root of 7 over the hypotenuse. So cosine will be square root of 7 over 4. But since the angle is in the second quadrant, it means that cosine will be negative square root of 7 minus square root of 7 over 4. Question 7. Given the following graph of y equals sine 3x, find the maximum value, minimum value, amplitude, and period of the graph. Based on the graph, find the solution of sine 3x equals to 0. For 0 less than or equal to x less than or equal to 2 pi over 3. Here is the graph of y equals to sine 3x, and we can find out the maximum value equals to 1, which is of course the y value of the point of the maximum point in this graph. The minimum value will be negative 1, which is the y value of the minimum point of this graph. And the amplitude equals to 1, just seeing from the coefficient of sine 3x, which is 1. And the period equals to 2 pi over 3, because it ends up with 0 in 2 pi over 3. So sine 3x equals to 0, it means that we are going to find the solution of this equation sine 3x equals to 0, or to find the value of x from the interval of 0, x equals to 0, until 2 pi over 3. So using this graph, it will be very easy to find out the solution. Firstly, the solution from the graph is always the intersection of the graph with the x-axis. So we can find out that there are 3 points of intersection of the graph and x-axis. The first one is 0, 0, so it means that we see that x equals to 0 and x equals to pi over 3 and x equals to 2 pi over 3. Question number 8. The pH value of ketchup is 4. Find its hydrogen ion concentration in moles per liter. So this is the solution to this question. Firstly, we know that pH equals to negative logarithm of H plus, which is the hydrogen ion concentration. We are borrowing the term of pH value in chemistry because this is the application of mathematics in chemistry. Okay, next. And after that, since the logarithm is based on 10, it means that the hydrogen ion concentration, or H plus, equals to 10 raised to the power of negative pH. Substitute the value of pH equals to 4, the H plus equals to 10 to the power of negative 4 in moles per liter. Question number 9. Find the gradient of the curve y equals in bracket x plus 1 times in bracket x minus 7 at x equals to 1. So here is the solution, or how to solve this question. Firstly, this is the curve y equals to inside bracket x plus 1 times inside bracket x minus 7. So if we want to reduce this bracket, or let's say multiplying this bracket to the other bracket by distributive property, we have y equals to x squared minus 6x minus 7. It will be very useful to find out the gradient. So we know that the gradient of a curve at any point equals to the derivative of the curve at the point. So to find out the gradient, it means, and it always means, to find the derivative of the curve. And after that, we can substitute the value of x equals to 1. So y prime, or the first derivative of x squared minus 6x minus 7, equals to 2x minus 6. This is the gradient of the curve. And after that, at x equals to 1, it means we are going to substitute the value of x equals to 1. So y prime equals y prime of 1 equals to 2 times 1 minus 6 by substituting x equals to 1. So 2 times 1 equals 2, 2 minus 6 equals to negative 4. So the gradient of the curve equals to negative 4. Question 10. Find the intersection of the graph of y equals to x squared and 2x minus y plus 8 equals to 0. So to solve this question, we know that the intersection between a curve and line is just the same to solve the simultaneous equations. So let's say the first equation is this, y equals to x squared, and the next equation is the second equation. So based on our experience, it is easier to find out y from the second equation. So y equals to 2x plus 8. And of course, let's say this is the third equation. We can substitute the third equation into the first equation because they look similar. So y equals to x squared and y equals to 2x plus 8. Since y equals to y, it means that x squared equals to 2x plus 8. So we construct the quadratic equation like this: x squared minus 2x minus 8 equals to 0. So by factorization, x minus 4 times x plus 2 equals to 0. From here we obtain the values of x equals to 4 or x equals to negative 2. Since we already knew the value of x, so we can substitute x to find out the value of y. So for each value of x, we have this one: x equals to 4, y equals to 16, and for x equals to negative 2, y equals to 4. So there are 2 points of the intersection of the graph and the line in the question. The intersection point are 4, 16 and negative 2, 4. Question number 11. Find the area of the quadrilateral with vertices 0, 0, 2, 3, 1, 5 and negative 2, 4. The solution has to be started using a sketch of the diagram of all points. So point A 0, 0, point B 2, 3, point C 1, 5, and point D is negative 2, 4 are all put in the diagram. So every 2 points will be joined by a straight line, A to B, B to C, and C to D, D to A. So this is the area. So this is the region, decided region, that we need to find out how much the area. This and this notation will be the formula to find the area using the vertices. But before we put all the numbers here, you have to know we can start from any point in the diagram. So here I start with point A 0, 0, and I put 0, 0 from x. This is the value of x, and this is the value of y. 0, 0, 2, 3. 2 is the value of x, and 3 equals to the value of y. The next 1, 5, negative 2, 4, 0, 0. So using a trick to find the determinant of a matrix, it will be like this: 0 times 3 equals to 0, 2 times 5 equals to 10, 1 times 4 equals to 4, negative 2 times 0 equals to 0. And after that, the other diagonals like this: 2 times 0 equals to 0, 1 times 3 equals to 3, negative 2 times 5 equals to negative 10, 0 times 4 is a 0. So, and after that, we can subtract the total number of red numbers by the total number of blue numbers. So this will be like this: the area equals to 1 over 2 times the total of number in red minus the total number in blue. So firstly, you have to add up all the numbers in red and subtract it to the total number of the numbers in blue. So 14 minus negative 7. 14 minus negative 7 is 21. So the area will be a half of 21 square units, or 21 over 2 units, or 10.5 square units. Question 12. A circle with the center 2, 2 touches x-axis and at the same time also touches y-axis. Find the equation of the circle. So to find the solution for this question, we need to sketch the diagram once again. So this is the Cartesian diagram, and put the center 2, 2. Of course here, this is point A 2, 2. And the circle must touch x-axis. So if we can imagine and sketch it in the Cartesian diagram, the circle will touch x-axis perfectly when the value of x equals to 2. And at the same time, the circle will touch y-axis at y equals to 2. So the center is 2, 2. As the circle touches x-axis and y-axis at the same time, the radius will be 2. We can see it from the diagram. So this is the one form of the circle: x minus a squared plus y minus b squared equals to r squared. A is from the center, b is also from the center. A is the value of x in the center, and b is the value of y in the center. So we can write like this: x minus 2 squared plus y minus 2 squared equals to 2 squared, because r equals to simplify to be like this: x minus 2 all squared plus y minus 2 all squared equals to 4. Okay, this is the question number 13. Given the function f, x equals to sine 3x to the power of 6 plus 3, find the value of f prime of pi over 3. Here is the solution. Firstly, this is the original function, and of course, using some rules in differentiation, we'll obtain f prime x equals to 3 times 6 times sine to the power of 5 of 3x times cosine of 3x. Simplifying this will give f prime equals to 18 sine to the power of 5 of 3x times cosine of 3x. Substituting the value of pi over 3, so we will obtain f prime of pi over 3 equals to 18 sine to the power of 5 of pi times cosine pi. And of course, because we know that sine pi or sine 180 degree equals to 0 and cosine pi equals to negative 1, so this will be 0. This is question number 14. Find the following definite integral. This is the definite integral of 3x squared minus 2x plus 1 with respect to dx, with the lower boundary negative 2 and upper boundary 2. So the solution is to find out the integral or the antiderivative of this function. So it will be like this: x cubed minus x squared plus x, and then we can substitute the value of the boundaries. By substituting the upper boundary x equals to 2 inside the value of x, or inside the term of x, it will give the result like this: 2 cubed minus 2 squared plus 2. And after that we subtract the result into by the value after we substitute the value of x equals to negative 2 terms. So we'll obtain 6 minus negative 14 equals to 20. That is the final result. This is question number 15. Find the area of the region bounded by the curve y equals to x times in bracket 4 minus x and the x-axis. And the solution, you start by sketching the curve first, so that after you sketch the curve, you will obtain the curve like this. And this is the area that we need to find out. And of course, from the sketch, we see that the lower limit of x will be 0 and upper limit of x equals to 4. That will be very useful while we are doing the calculation of the area using integral as follows. The area as an integral will be the integral of x times 4 minus x dx, with the lower limit equals to 0, upper limit equals to 4. The integral of this one equals to the integral of 4x minus x squared as we multiply x inside to the bracket. So the integral of 4x minus x squared equals to 2x squared minus x cubed over 3, lower limit 0, upper limit 4. Substituting the values of upper limit and lower limit, we will obtain like this, and the result equals to 10 2 over 3 square units.